The Agilent 6230 LC-MS is an open-access instrument in the Materials and Molecular Analysis Center at the Analytical Resources Core. Using this system, you can accurately identify the molecular weights of compounds in a sample. If your sample is a mixture, the liquid chromatography system can be utilized to efficiently separate the components of the mixture prior to mass analysis. Quantitation of an analyte is also possible with this system. Generally, this system consists of three major components. First is the Ultra-High Performance Liquid Chromatography System, or UPLC, which contains a binary pump system, a thermostated sample compartment, an autosampler, and a chromatography column compartment. The binary pump can draw from two different solvent bottles simultaneously. These bottles sit on top of the instrument. The next major component is the ionization source. We have three different ionization sources that are compatible with this instrument: electrospray ionization, or ESI, direct analysis in real time, or DART, and multimode ionization, or MMI, which is a combination of both ESI and APCI. APCI stands for atmospheric pressure chemical ionization. The ESI and DART sources are used most frequently on this system. The third component is the mass analyzer, which is a time-of-flight mass spectrometer, or TOF. The Agilent 6230 TOF has some important features that enable highly accurate mass measurements of a wide variety of molecules. These are mass accuracy at less than 1 part per million, resolving power greater than 20,000, acquisition rates up to 40 spectra per second, automated tuning and calibration, and finally, this instrument can measure molecules with mass-to-charge ratios between 20 and 20,000, which makes this instrument suitable for measuring small molecules like organic natural products and pesticides, all the way up to large macromolecules like multiply charged intact proteins. There are a variety of ways that samples can be analyzed using this system. Samples that are soluble in an LC-compatible solvent can be either analyzed directly using flow injection analysis or first separated with chromatography. For flow injection analysis, a sample is first injected to the system by the UPLC autosampler. It bypasses the LC columns, is ionized by either the ESI or MMI source, and then the mass is analyzed by the TOF within a few seconds of injection. The resulting mass spectrum includes all ionizable analytes in the sample. For mixtures that require chromatography to separate analytes, after injection, the sample is separated by affinity in an LC column. As they elute, analytes are ionized in either the ESI or MMI source, and then analyzed in the TOF mass spectrometer separately. A syringe pump infusion method can be utilized for samples that are not soluble in LC-compatible solvents, but still require the ESI or MMI sources for ionization. The TOF mass spectrometer analyzes all ionizable analytes together when using this method. The DART source also allows users to bypass the solubility requirements of the UPL system by allowing a wide variety of sample formats to be placed directly into the source and then ionized into the TOF mass spectrometer. Mass spectrum results are captured nearly instantly and include all ionizable analytes. To help you decide what analysis technique is right for you and your samples, let's take a more detailed look at our two most popular ionization sources, ESI and DART. Electrospray is an ionization technique that can ionize a wide variety of samples, typically with little to no fragmentation of the parent ion. The minimization of fragmentation in the ESI process is why ESI is considered a soft ionization technique. In ESI, the solvated sample is introduced into the source by a nebulizer needle, where it's sprayed into a strong electric field and ionized. The high-voltage glass capillary helps to direct the generated analyte ions towards the ion-focusing optics that lead to the time-of-flight mass analyzer. How does electrospray ionization produce ions? When the sample is sprayed through the nebulizer into the electric field, charged solvent droplets that contain analyte are formed. As these charged droplets are drawn to the capillary, heated drying gas is used to shrink the size of the droplets. The droplets continue to shrink until Coulombic repulsion exceeds the cohesive forces holding the droplets together, leading to droplet explosion. This process repeats, creating smaller and smaller droplets until the charge is transferred to the analyte as the analyte ions are desorbed into the gas phase. They are then able to enter the capillary and head towards the time-of-flight mass analyzer. Direct analysis in real time is another soft ionization technique that uses a heated stream of helium plasma to ionize solid, liquid, or gas samples with virtually no sample prep. First, an electric potential is applied to helium gas to generate helium plasma that contains short-lived energetic species, ions, and importantly, long-lived excited state helium atoms that are metastable. The plasma is then heated to a desired temperature and flows through the exit grid where a charge is applied to filter out any ions in the helium gas. When the heated gas hits the sample, it aids in desorption of the analytes if the sample is not already in the gas phase, and then ionizes them. There are a variety of mechanisms in which DART can create ions. In positive mode, for example, the excited species in the gas ionize water vapor through Penning ionization, eventually creating protonated water clusters. These can then transfer a proton to the analyte through chemical ionization mechanisms. From there, the charged sample is then introduced into the mass spectrometer capillary. To help you choose which source is right for you, let's compare the two sources we just talked about and the third option available, which is APCI. Both DART and APCI are suitable for small molecules, whereas ESI can ionize small molecules and larger biological molecules like proteins. ESI is best suited towards more polar species, APCI is best for less polar species, and DART can ionize a wide spectrum of polarities. To use ESI and APCI, the sample must be dissolved in LC-compatible solvent or injected via syringe infusion. DART requires little to no sample prep. Objects or materials can be held directly in the source. ESI and APCI are compatible with the LC system and can be paired with chromatography, whereas the DART requires each sample to be manually loaded. In ESI, ions are formed in solution in the liquid phase, and in DART and APCI, ions are formed in the gas phase. Therefore, volatility of analytes is not required for ESI, but both DART and APCI require analytes to be at least somewhat volatile. ESI is the preferred choice of ionization technique if the analyte of interest has insufficient thermal stability for DART or APCI. ESI can form multiply charged ions, particularly for large biomacromolecules like proteins. DART and APCI generally form singly charged species. Once the analyte molecules are ionized and in the gas phase, they are introduced into the mass spectrometer. The charged particles are drawn into a series of high-voltage transfer optics that start with a glass capillary. These direct the flow of ions towards the mass analyzer, while vacuum pumps reduce the pressure in stages to reach high vacuum, removing any particles that may impede the path of the ions. The beam of ions is passed through the ion pulsar, where a high voltage is applied to start the ion's flight through the tube perpendicular to their initial path. This geometry increases resolution by minimizing the effect of the ion's entrance velocity into the ion pulsar on their eventual flight time. At the opposite end of the flight tube is an ion mirror, which reverses the direction of the ions towards the detector, doubling the flight path of the ions. The time it takes for the ions to reach the detector is used to calculate their mass-to-charge ratio relative to a calibration of known ion flight times. Agilent 6230 LCMS is one of many mass spectrometers available here at the ArcMMA that may aid you with your research. If you would like to be trained as a walk-up user, we have more instructional videos to assist you. We also provide full-service mass spectrometry analysis on this and every other mass spectrometer in our lab, where a staff member can prepare and analyze samples for you. Hope to see you in the Arc soon, and thank you for watching.